Okay. Well, thanks everyone for joining us, and welcome to our second ever ParslFest meeting. This is a picture from last year, and I guess it probably won't be quite as fun this year as we're not in person. We don't have the same conversations and great lunches that we had last year, but hopefully next year we'll be back in person. Of course, this photo is also known as the famous Yadu photo because he's the only person that's looking in the wrong direction there. He doesn't like me reminding him of that. I should say that we have a code of conduct, so I think this is something you see a lot more in meetings these days. If you want to take a look, it's on our GitHub page, so this meeting will be part of that, under that code of conduct. Really, it's pretty simple. We just want to have a sort of positive, friendly environment as part of the Parsl project, and that sort of includes everyone that is contributing using Parsl. If there are any problems, there's an email list at the bottom that goes to Dan and myself. If there's a problem with Dan or me, probably send the email to the other one. Okay, so I think there's a few people here that haven't, or at least a few people signed up that haven't used Parsl before or don't know what it is. So I thought I'd include one slide description of Parsl. There is a link on the program to a longer tutorial we gave a year or so, or maybe a couple of years ago now at the Blue Waters Symposium. So if you are new and want to find out a little bit more, have a look at that video. You can probably watch it on 2x speed and get through it pretty quickly. So essentially, Parsl is a parallel programming library for Python, and the aim really is to make it very easy for very different types of people to express parallelism in their Python scripts, and then to be able to execute those programs on arbitrary parallel distributed computing infrastructure, and to take advantage of the many cores and nodes you have available to you. So we've really focused on trying to make the model simple and easy to express. I know some people don't like me saying simple, but the model is really that you take your Python scripts, you annotate the functions with these little app decorators you see there, Python and Bash apps, and those decorators allow or tell Parsl that this function can be executed asynchronously and executed in parallel. And then you can string together these functions in standard Python code where each call to this function will return a future. You can pass that future from one app to another app, and you start to establish a DAG, a dependency graph behind the scenes that Parsl, the internal logic of Parsl, will then use to map that to execution resources. Parsl scripts, of course, are independent of where they run, so you can write your Parsl script once and then change the configuration such that it will use multiple threads on your laptop. It might use multiple nodes on a supercomputer. It might use an inbuilt Parsl executor, the high throughput executor. It might use an external executor such as WorkQ that can manage resources in a more advanced manner. And all of that is completely abstracted from the actual program that you're executing. So this year's been a pretty busy year for the project. We're into now, I can't remember what year when was our first release of Parsl? 2017, Yadu? Would that be right?
I think so.
We should probably know that off the top of our head. I think 2017. So we're now 3 years into the project, and we decided this year that we'd basically implemented everything that we said we would as part of our roadmap. We thought the software was fairly stable, was being used by a bunch of people, and we weren't getting too many complaints. So we decided it was time for our 1.0 release. That was a big chunk of work, just getting everything together, making sure everything was sort of well tested and ready to go. And in June, we released the 1.0 version. Over the year, we've developed a bunch of new features. Some of these you'll hear about today, like the WorkQ executor, which we thank our friends at Notre Dame for contributing a bunch of, well, not only WorkQ, which is a fairly amazing executor, but also working with us to integrate that and contributing a lot of development time. We've made some enhancements to the high throughput executor, mostly around making it scale in and out, making it easier to use, like automatically detect addresses, making it more robust, optimizing or improving the serialization libraries. There's a bunch of other things there. One that's probably, for those of you that have used Parsl for a few years, one that probably you noticed more than most was the movement away from using strings to using files as passed in and out of apps. And that just makes it easier for Parsl programs to be more portable, so they're not tied to the actual execution infrastructure that they're running on. And then behind the scenes, there's been a lot of work on robustness of code in terms of our development processes. We've added a lot of type checking, more standardized error handling, which you don't necessarily see, but you probably benefit from in some way or another. And we had a great contribution from a commercial company that added a bunch of make files that have made it a lot easier for us to build and test the Parsl code base. So I showed a slide like this last year, and I think the good thing as I revisited it this year, is that we can clearly say that the Parsl community is continuing to grow, and it's growing faster this year than it has before. So our PyPy downloads are up by 130,000 downloads this year, taking us to 200,000 over the course of the project. And the interesting thing there is, of course, we've only released maybe a few, maybe 2, 3 releases this year, because we're more stable and going to longer release cycles. In previous years, we've released, I don't know, maybe 8, 9 point releases. So having that many PyPy downloads is not a result of us releasing a lot of software. It's a result of people actually downloading it. Similarly, we see the website's up. Half of our new unique visitors are in the last year. And then in terms of the code, we're up to 46 different contributors to the project. Of course, we thank all 46 of them for everything they've contributed. And we're up to 41 systems that are using Parsl under the covers. So we're seeing a lot of adoption of Parsl, not just as like an end user scripting environment for writing applications, but as a library or a platform for building more advanced capabilities on top. And you'll hear about a few of them today. Our new FunkX project. There's things like the Data and Learning Hub for Science, which is a platform for publishing and running machine learning models. There's the QC Archive system out of the MOLSI Institute, which we heard a lot about last year. I don't think we've got a MOLSI talk today, but they're huge users of Parsl. In terms of an update of where we sit on the, maybe not the financial side, but the sustainability side, I think we get often asked by projects, well, what's the story with Parsl past the grant? What happens? Are we just going to disappear and no longer be useful? And the answer clearly here is no. So I think many of you will know that we have a really great grant from the CSSI program, or SI2 program, I guess, when it was actually awarded, that funds us through the end of, well, roughly 1 year from today. That grant will end, and that funds essentially all the development of Parsl, all of the support of users, et cetera, et cetera. But the good thing is we've actually managed to, well, in some cases get new grants, in some cases partner with other people getting grants to support either direct or indirect development of Parsl. Probably the one that's most notable is, and I'll talk a little bit about this in the next slide, is the FunkX project, which is it uses Parsl, basically servicifies the Parsl code such that you can access it remotely through sort of web standard models, and that'll support Parsl development as part of the endpoint that sits on the remote resource. We've had a great deal of support from the Dark Energy Science Collaboration. I see Tom is here. I think I saw Heather here as well. So we have an Argon project, an LDRD project that supports development of workflows for Desk, and also supports enhancements to Parsl. And you'll hear from, I think Tom is speaking today, probably about some of the work that he and Ben have done on developing workflows and some of the enhancements to Parsl there as well. We just received a new LDRD from Argon to work with the Balsam team at Argon and apply Parsl and Balsam together as a way of addressing real-time workloads at the Advanced Photon source. We have a new project with our colleagues at Brookhaven and Lawrence Livermore called ExaWorks, which Dan will speak about in probably about half an hour. And this is really looking at addressing the exascale workflow problems, and Parsl is one of the key players there. We're part of a High Energy Physics Institute or Center, DOE Center, where with Shantanu Jha, we're leading the workflows angle. And then there's a new PSAP award to UIUC that Dan's involved in that's going to support some Parsl development. And I think Kun is going to present later today on how they're using Parsl on that project. And of course, we're open to new collaborations and opportunities. Please let us know if you're interested in using Parsl or partnering in various proposals or supporting Parsl in other ways. So just briefly, I wanted to highlight FunkX. Originally, we had a talk scheduled for FunkX, but we were somewhat oversubscribed, so we removed it from the program, thinking that I could cover it in the welcome. So FunkX is a new project that builds on Parsl, and you can think of it as almost servicifying Parsl to run on a remote system, on a supercomputer or a cluster or a laptop, and then being able to route functions, individual requests to that endpoint via a reliable cloud service, almost like the Globus model for reliability, security, cloud managed execution of things, and then the Parsl model for how you're actually provisioning resources and deploying work to those resources. We're calling this model federated function as a service. So the idea being that, like the grid, we're federating different resources and providing this fabric for basically taking these very these small and portable functions and then executing them on different resources. Endpoints can be basically just like Parsl, you pip install funkex, you start up an endpoint by using a Parsl configuration, which I think you're all probably all fairly familiar with. And then you register that endpoint once with the cloud service, and then you can just connect to the cloud service through an SDK and route functions for execution on that endpoint. You'll hear a few talks today that are using funkex in various ways, and just as you're hearing that and thinking, well, this doesn't seem very relevant, just remember that funkex is Parsl under the covers. We sell this as well as a model of very easily turning any machine into a function serving endpoint. And then we're exploring this idea of being able to route functions to the most appropriate remote endpoint. So you might want to pick something because it's available at the time, because it's cheapest, because the resources are most suitable for what you'd like to execute. Okay, so that was sort of a tangent, but hopefully, I guess in the next few years, we'll probably add a funkex fest to our ParslFest. So goals for the meeting today. This is sort of high-level goals of what we're hoping to accomplish, and I think there are probably goals that you are hoping to accomplish, and please let us know if there are ways we can better support what you would like to get out of this meeting. So ping me on Slack, and we can. I think we're pretty agile, so we can think about how we adapt for things that would be most useful for you. But our number one goal really is for people to share experiences using Parsl in different domains. There might be overlap, there might be opportunities for people to think about working together or sharing configurations or sharing Parsl scripts, etc. I will say there's a slight asterisk there. This year, our program, it was much more difficult to align similar talks due to time zones and availability. So the sessions are less well themed than they were last year. So it might be a little bit harder, but we'll publish all the slides and people can have a look for the ones that are interesting to them after the meeting. We'd love to create a larger and more engaged Parsl community. So we've added some activities here for people to meet one another. Hopefully it's an opportunity that you'll be able to meet people that will be able to help you in the future. We've included some tutorials at the end of each day that will introduce more advanced topics, things that we're hearing from the community, that the problems that people are trying to solve that we thought we could wrap up in a way that you'd be able to take that code and potentially adapt it for your own problems. We have office hours after each day. So this is just a half an hour, come and chat about anything. Doesn't need to be Parsl. It can be just a general catch up with any of us. We'll all be around. And then any other topics, as I say, any topics that would be useful to you, let us know. One question we get a little bit, well, maybe quite a lot, is how can people in the community help support the Parsl community? So we came up with a list here. I would say this is not complete, but this is a list that popped into our mind as we were preparing the slide, and we've tried to order this from sort of easiest to most difficult. So one thing you can easily do is go and start Parsl on GitHub. We'd love to have more people join the Slack channel, and feel free to ask and answer questions there. We'd appreciate if people cite or acknowledge Parsl in their papers and presentations. One thing that really helps us actually is letting facilities and research computing centers know that you're using Parsl. I think this is one that helps us get support from the facilities. If you've been to the NERSC documentation lately, they wrote an amazing guide of how to use Parsl on their systems. And I think that came about from hearing about the amazing things that the desk group and others were doing at NERSC. Let us know how you're using Parsl. This is great for us to include in our slides, great for us to include in our reports to funding agencies, etc. Please, if you run into a problem with Parsl, don't just write it off and move on. We'd love for you to just create an issue or ping us and let us know what the problem is, so that we can actually start to accumulate what the biggest problems that are facing people. We love to see people building tools and libraries on top of Parsl. As I said, this is becoming more and more common. I think it's a useful way of abstracting that lower level, the layers of parallel computing that cause problems. And then, of course, if we're a completely open community, so feel free to contribute code, write pull requests, fix bugs, come and develop new features, contribute in any way that you would like. And feel free to ping us again if you'd like to get involved but don't know where to start. We do this a lot with students and things like that. So ping us and let us know, and we'd be happy to help walk you through sort of the first PR, et cetera, et cetera. There's a bunch of people involved in the Parsl project. I thought I'd enumerate some of the people you'll see today. So Yadu, Ben, Mihal, Dan, Georgiao, Mike, and Anna. They'll be around today coordinating various parts of the program. And of course, all the other contributors and users of Parsl that have contributed in various other ways. So with that, I'll move on to an outline of the program for today. So as I said, we had to rethink things a little bit, given we're not in person, and what we decided was, given we've got people from Singapore and Sri Lanka and Europe and the West Coast, that we would try and do 2 different sessions at completely different times to try and hopefully accommodate different time zones. So today, obviously you've all made it here. We're going to go 9 till, I don't know, 1:30ish, depending on how many people show up in the office hours. And then tomorrow we'll kick off at, and of course I'm saying all this in Central Time. Sorry, I thought I added, maybe I added UTC to the email, not to the slide. Someone, I guess you're all here on time, so you know what time it is. And then tomorrow we'll kick off at 1 p.m. Central. As I said, the sessions maybe are not quite as well aligned as they were last year. And that's pretty much solely, like, this first session is mostly people from Asia and Europe. And then we've got more of the West Coast in the afternoon. So we've got 2 sessions today kicking off now. Don't worry, we added a little bit of buffer there, so don't worry that I'm running over. We're going to have a virtual meet and greet. Anna's prepared a nice icebreaker activity. It's actually a service that I think is sort of like speed dating to get people chatting about random things. And then we'll come back at 11 o'clock for session 2. Our breaks, we're going to use the gather.town service, which people have probably seen before. We used it for our incoming PhD students the other day, and I think it worked relatively well. And then we've got a couple of longer tutorials this afternoon. I should also say the talks, given we have 22 talks and we want to cram it into basically one day, the talks are going to be sort of capped at 10 minutes, including questions. So we're looking at sort of 7 or 8 minutes of talking time, and then 2 or 3 minutes of questions for each talk. And as I said, office hours at the end of the day. And then tomorrow we're going to repeat the same sort of schedule. We'll use GatherTown for the breaks again, and have a couple of tutorials to finish off ParslFest 2020. With that, I should say thank you just quickly to our funders. The NSF really has supported this project in an amazing way with the Parsl grant that's enabled us to build the software and work with the community. We've also received other money from, or funding from the DOE. We received Amazon credits. UChicago, Argonne, and Illinois support the project in various ways as well. Any questions? We probably have 1 or 2 minutes if anyone has any questions. And questions, feel free to just unmute yourself and ask questions. I think we'll do away with any hand raising and things like that, mostly because I struggle to keep track of anything. Okay, well, no questions. Maybe I'll hand it over to Dan, who is going to chair the first session.